Hi everyone, I'm Jason Anderson. I work at a company called GameChanger. We do stat tracking, scorekeeping, streaming video for youth sports. And today I'll be talking about the dirt roads of DevOps and how we can provide more on-ramps to highways, allowing everyone to consume platform capabilities without having to be a AWS, Docker, database, or Linux expert. But before we talk about that, let's meet our humble engineer, Britt. Aside from his very admirable base stats, Britt is a great developer. He knows enough to be dangerous in AWS, also has some Datadog experience. Britt works for a sports social company and is tasked with building out a feature that allows users to upload sports video clips to an athlete profile. That athlete profile can then be shared with family, friends, coaches, recruiters, so they can see sports highlights from the athlete. One of the requirements for this solution is that the clips be transcoded into a standard format for the company. So this is the architecture that Britt and his team settled on for this. We have a mobile device that calls a API in order to get a S3 signed URL. This S3 signed URL is then used to upload a video clip to a S3 bucket. That triggers a transcode job event that lands in a queue, which ends up triggering a Lambda. The Lambda puts some initial metadata into an RDS database about the clip, like the name, description, that sort of a thing of the clip, and then triggers AWS Media Convert, which does the heavy lifting of transcoding that clip to the standard format by the company. So Media Convert will pull the clip from the upload bucket, and then it'll do the transcode work, store it in a clip archive so it can be viewed. After that process is done, Media Convert emits an event saying that the transcode is finished, which gets queued up, triggers a Lambda that goes and updates metadata in the database to say that, hey, this clip is available. Now it can be viewed by family, friends, coaches, and recruiters. And then users are able to either use the app or the website in order to stream the video clip through CloudFront distribution. So Britt and his team make the necessary updates to the app. They test it, they deploy it, users are happy. They're able to upload clips to their athlete profiles and share them with family and friends. So what could possibly go wrong? Well, everything. Maybe the clips don't upload correctly. Maybe they don't transcode. Maybe there's something broken with Media Convert. The files could unintentionally become public. So if a user is scoping their video to only show it to family or people with a link, they don't want to show their clips to everyone. They could become public. Maybe clips can't be viewed. There's something wrong with the streaming of them. Maybe metadata isn't being stored, so you're paying for the video storage, but it's not linked to any metadata. Maybe the database goes down. We potentially don't know why things are broken and are relying on users to report that something is broken in the app, which is never a great feeling. And then there was a lot of unknowns with Britt's implementation around the complexity of it, the time it would take to develop it, that sort of a thing. Sorry, Britt, you had to travel on the dirt road of DevOps. The problem here is that Britt had a large cognitive load. Not only did he have to think about his feature development and unit testing and integration testing, he had to think about all the DevOps-y type things. So he had to make sure that monitoring and alerting were in place so that if this process failed, that he would be alerted to it. He had to make sure that things were encrypted in transit, at rest, that sort of a thing, that IAM permissions were followed properly. Backups and retention, had to make sure that that Aurora database was being backed up in case of a disaster. He had to handle fault tolerance, scalability, cost, all those types of things. And He also had to not only write the end user documentation for how this feature can be used, but he also had to write the support documentation and run books for if there's a problem with a part of the system. The dirt roads of DevOps have lots of unknowns. So dirt roads are great for prototyping. They provide the ultimate freedom and flexibility. You really have an open field. You can go nuts with prototyping. For things, it's also good for things that have low reuse. But that's kind of where the benefits end and the cons for dirt roads become more apparent. So for example, lack of traffic control. The same capability might be implemented multiple ways by different teams. And those solutions might not scale, and the teams are going to be coming to the platform team to ask for support all the time. Dirt roads are much slower and more difficult to navigate because the engineers don't have guidance on how to best consume platform capabilities and end up having to reinvent the wheel. They don't know that another team did something similar or the right way of doing things, so they just try their best to do it. Risky travel is an issue with dirt roads, in that security is very inconsistent and highly dependent upon the engineer who originally built the solution. And they require constant high-touch maintenance by the original owner of the solution. So Britt will probably end up owning this solution until he leaves the company. Quality is also very inconsistent. And is highly dependent on the engineer. So good thing Britt is a good engineer. What if there was a better solution? What if there was a team of experts who had already gone down some of these dirt roads and paved them? Paved roads, it's a DevOps concept that started at Netflix. Spotify calls them golden paths. Regardless of what they're called, the goals are relatively the same. Paved roads are application independent and they're product focused. They provide everything that is required to deploy and operate a platform capability. They're opinionated implementations based on the company's platform team's best practices and software pattern best practices. And they also can make assumptions about each other when different paved roads are combined. They can fit together like Lego blocks and work together. So an example of that would be a paved road for a CDN working with a S3 bucket in order to serve up a single page web app or serve static content. And we want engineers to be able to specify the minimum amount of information to configure and deploy a platform capability. They shouldn't have to worry about what subnet do we want to land this database in, or what should all my security group configurations look like, that sort of thing. So we'll talk about what a paved road contains, but I want to give you a few examples to think about as we walk through that. It's all the kind of normal commodity types of patterns that you're used to, such as databases and scheduled jobs and microservices. So what do paved roads cover? It's really a lot of what we talked about for Britt's cognitive load. What he had on his mind is cognitive load. So we want to cover any sort of monitoring and auditing that is not application specific. We want to enforce security best practices and ensure that backups are configured and retention aligns with company standards. We want these paved roads to be fault tolerant, yet and have automatic recovery when possible. They need to be scalable, yet cost efficient. We want to have well-defined access controls that abide by the principles of least privilege. Also have runbooks, usage documentation, examples that app teams can use in order to build into their own processes, so they're not having to say, oh, when you get this error, this is the runbook that you follow. Paved roads are also, they're easier for the platform team to support as well, because platform team can develop a paved road for a CDN, and then when a app team is having issues with that paved road, the platform team can look at how they're calling the module, and they have a lot of context already about what that module contains, what is inside that module, and how those pieces interact. They're not having to go look at an app team's code that is a bunch of random resources, CloudFormation resources or Terraform resources. We also want paved roads to cover deployment pipelines, so that way every project doesn't need to reinvent the wheel of building a Docker image or pushing files to S3, those types of patterns that we see all the time. So how do we implement paved roads? At my company, we use a lot of Terraform for it, especially if there's infrastructure involved. One of the reasons why we use Terraform is because there's a plethora of providers out there. So there's Datadog, AWS, it crosses monitoring, it crosses cloud infrastructure, any sort of DevOps tool that you can think of probably has a Terraform provider that you can consume. Another big reason why we use it is because it allows us to combine the infrastructure with the monitoring, and have those live side by side and have them play off of each other as well. We also use it to enforce best practices, so things like naming conventions, high availability, security, tag enforcement, those types of things. And calling it from a consumer perspective is relatively easy. We'll get a little bit more into the developer experience in a bit. So with the architecture that Britt developed, he has a few paved roads in here. We're going to talk about two of them. We're going to talk about the S3 buckets and the Aurora database and what those can contain. First, we'll look at a S3 bucket. For a paved road for an S3 bucket, we can bake that bucket policy into the module, so we can make sure that that is least privilege. We can enforce security or enforce encryption in transit and at rest. We can give them the option of sending some objects to Glacier storage that aren't accessed as frequently, and reduce our cost on storage. Datadog monitors, we can build in alerts for if a principal is having issues accessing a object in that S3 bucket, or if that S3 bucket grows dramatically within a small time span. We can have Datadog alerts alert us when those comes off, when those happen, and alert the product team too, so they can dig into it to see if it's an application issue. Replication, I don't know if how many of you have configured replication with S3, but it can be a pain. Baking that into the module makes it very easy for developers to say, I want this data replicated into a different region, a different AWS account for disaster recovery, or just because there's another system that needs to pick it up and use it. And we also enable versioning and have backups that abide by our company standards and help in the case of ransomware or oopsies on the developer's part. And calling the module is relatively simple. Like I have an example down here of the bare minimum requirements, and you get a lot of the stuff baked in. Here's another paved road. This one's for a database. We're able to bake in high availability by default, backups again, encryption, baseline infrastructure monitoring, so we can catch any sort of infrastructure related or performance issues. We bake RDS proxy in, which is it's a connection pooling tool. so that way the database doesn't have to spend CPU and memory managing connections, and we can offload that to a different service. And seamless user management. So since we are using Terraform, we're able to use the Postgres provider that allows us to create those users right away after the database spins up. And the developer can then go in and start running migration scripts in order to create tables and that sort of thing. Here's a quick example of the bare minimum that's required for spinning up an Aurora module. In our case, we just have them provide the usernames, and we auto-generate the passwords. We can stuff those into secrets manager or something like that for other processes to pick up and the apps to pick up automatically. So here's a more complicated paved road that combines multiple components in it. So a CloudFront distribution, which has all the security tooling around it that you would expect from a CloudFront distribution, like the WAF and TLS and access logging. That can all be baked into a paved road that is on its own, but it can also be combined with a S3 bucket Terraform module in order to create a single page web app or static content hosting. We can also build with GitHub Actions the pipeline to publish into S3, so that way if a project needs to build, use Webpack or something like that in order to build the app to push, we have a standard process in order to do that. And that way teams don't have to reinvent the wheel with that. So a lot of developers don't know Terraform. We don't want them to necessarily learn Terraform. That's where CDK-TF comes in, Cloud Development Kit for Terraform. CDK-TF allows the developer to write in their native programming language, like TypeScript, Python, etc. And then CDK-TF will automatically generate the Terraform on the back end. And you're just able to have it invoke the paved road Terraform modules, so that they say, I want a database, right in their TypeScript. They can say, I want a database. Here's the name of it. Here's a little bit of additional information on it, and check it in, merge it. It can get deployed. That infrastructure can get deployed at the same time as their code. Using a tool like CDK-TF also allows flexibility in passing configuration values between TypeScript and your app code and the infrastructure. So for example, if you are using SQS, you can have a developer add on to a enum or something like that in TypeScript and consume those same enums, same configuration values in CDK-TF in order to generate module calls to spin up SQS queues or something like that. So it allows to bring those pieces of code closer together. So this is an example, TypeScript example. It looks very similar to a Terraform module, native Terraform module invocation, just a TypeScript syntax. So in summary, dirt roads, they're highly flexible, but there's low consistency there. Brit has to own everything from end to end. Not only his code, but the infra monitoring ops, all that sort of stuff. They're slow to build, hard to maintain. There are a lot of times they're one-off situations that they're built, or times where you think it's going to be a one-off, but it's not. Security and observability are often missing from these patterns because the developers are focused on getting their code work, and the infrastructure is kind of secondary, and the DevOps tools are kind of secondary. There's a lot of times low reuse and high risk to paved roads or to dirt roads. Paved roads are nice because they're platform managed. You can have a centralized platform team that manages the paved roads and can focus on making those paved roads as developer friendly as possible. All the security, monitoring, backups, all that sort of thing are built in because typically that platform team is in charge of those aspects of it as well. So they have the subject matter expertise in order to build those patterns in. They're composable. You can put them together like Lego blocks. They're much easier to support for the platform team because the platform team knows the modules. They just have to dig into how you're invoking it and help you troubleshoot your application with how you're invoking those modules. And they're fast and repeatable, so I can create 100 databases with one Terraform abiding by our paved roads, and other tools and technologies you're not able to be that flexible. So in summary, we want to let the platform teams pave the road and let the engineers build the features.